Okay, all right. So this is the same thing as so finding cosine of 17 pi over 12 is the same thing as just taking the summation of 12 pi over 12 plus 5 pi over 12. And right here, so we know that the first angle is gonna be our alpha and this is gonna be our beta. But what we wanna do is kind of simplify this a little bit. So cosine of 12 pi over 12, that's just pi. And 5 pi over 12, well, we can't simplify this, so that's just gonna stay 5 pi over 12. And then from here, we can just use this formula, which is the sum of two angles. So you know that we have to take cosine of alpha, which is pi, times cosine of beta, which is 5 pi over 12, minus sine of pi times sine of 5 pi over 12. So at this point, you remember that what I showed you guys last time is that you can just evaluate this. And cosine of pi, you guys can actually just do it on your calculator. I kind of did that before. So cosine of pi, if you guys are using pi, make sure that that is on radian mode. So all you have to do is type in cosine of pi, and that's -1. So you can pop -1 there. And then cosine of 5 pi over 12. That's something you guys don't really know yet. That's something that we don't know from any given information. That's not on our table, that's not on our unit circle. So since that part is not on our unit circle and not on our table, then we actually have to find this part now. So that's the second part that we have to add. And then here in this other part, so we'll leave this for now. But now let's actually look at sine of pi. So if you guys type in sine of pi is actually 0. So if this is 0, then this is going to be 0 times this. So we don't even have to worry about this part because 0 times anything is just 0. So this will cancel out. So the only thing that we actually need to worry about is what is cosine of 5 pi over 12. This is the part that we have to do again. So we know how to do the sum of angles. We can separate 5 pi over 12 as 3 pi over 12 plus 2 pi over 12. So that's doing this whole process again, but just with this part, just with cosine and 2 different angles. So it's this time we're gonna do the same addition, but with a little minus sign at the end. So now we're gonna have that this is our alpha. What color should I choose? Let's choose a darker green. So this is gonna be our alpha, this is gonna be our beta. And then we're gonna do the same thing. Let's actually simplify this a little bit. So we're gonna have, so we're gonna bring down our -1. And then on the outside, we're gonna have cosine. Let's simplify this. So we're gonna have cosine of 3 pi over 12, that's pi over 4, plus 2 pi over 12, that's pi over 6. And now let's actually do the whole change of everything. So again, remember that we don't have to bring this part down because sine pi is just 0, so that just cancels this term out. Because anything times 0 is 0. Okay, so now let's go back to this formula. The formula says that we're going to take cosine of alpha. I moved them. So this is our alpha, and this is our beta. So we have alpha. So this is going to be equal to negative. I'm going to put that -1 outside. -1. This is going to be cosine of pi over 4 times cosine of pi over 6, because pi over 6 is our beta, minus, and then we have sine of alpha minus sine of alpha. Our alpha is pi over 4, so we're going to have minus sine of pi over 4, and then times sine of beta. Our beta is pi over 6, so this is going to be times sine of pi over 6. Oops. Sine of pi over 6. And now we're just again going to simplify this part. So now let's try to simplify this. So you guys can either use the table, either know it by memory, or whatever you guys want. So you guys have a negative on the outside. Cosine of pi over 6. What's cosine of pi over 6, guys? Mm-hmm.
45.
Nope. Oh, yes, pi over 4. Did I say cosine of pi over 6? I'm sorry. Yes.
Yeah,
Cosine of pi over 6 is the square root of 3 over 2. I meant to say cosine of pi over 4. What is the cosine of pi over 4?
Square root of 2 over 2.
Yes. So you have the square root of 2 over 2. So you have the square root of 2 over 2. Cosine of pi over 4 is the square root of 2 over 2. Cosine of pi over 6 is the square root of 3 over 2. And then this is going to be minus sine of pi over 4. That's also the square root of 2 over 2. And then sine of pi over 6. If you guys use a table or anything you guys want, that you guys can go all the way up here. And then you guys can see that sine of pi over 6 is right here. It's 1/2. So you guys can go, where's my work? Here it is. Okay, so this is just times 1/2. And then now you guys just simplify this. And then after you guys simplify this, you're done. So we can multiply the square root of 2 over 2 times the square root of 3 over 2. And something that I want to point out is that whenever you guys have 2 square roots, you cannot do any operation. You cannot do subtraction or addition between 2 radicals if they are not the same thing on the inside. The only time you can do something with the insides is if you're dividing or multiplying. If it is an addition or subtraction, you can't do anything unless they are the same on the inside. So I just wanted to clarify that. And then, because I know I didn't do a review of radicals, but this should have been from but yeah, so then I just wanted to clarify that part. And so whenever we take the square root of 2 times the square root of 3, now that we're multiplying the inside. So this is just going to be equal to the square root of 6 over, and then again, we're just going to multiply the denominator. 2 times 2 is 4. We have the square root of 6 times over 4 minus, and then this, we have a number on the outside, that's 1. The number on the outside here is kind of like 1 too. So this is 1 times 1, that's 1. And then the square root of 2, we just bring down. And whenever you guys do have a 1 on the outside, it's not really necessary to write this down. So you can just erase it or leave it, whatever you guys are used to, whatever you guys feel necessary. And then 2 times 2 is 4. So see, now we have a subtraction of two radicals. Since you guys have the subtraction of 2 radicals, we cannot combine these two. We're not going to combine the insides. We're just going to rewrite the same radical. So this is going to be 1 square root minus this other square root all over 4. So it's just going to be the square root of 6 on its own square root minus the square root of 2 on its own over 4 times -1. You guys can leave the little negative on the outside. That's completely fine. So this would be your answer. And that's how you guys can basically do any kind of problem that requires more than one type of addition angle. So again, I didn't really have control over who got what type of questions. So some of you guys only had to do it one time. So some of you guys got a simple angle where it might have been like 7 pi over 12. It might have just been this inside part. It might have just been 5 pi over 12 or 7 pi over 12 or anything. But some of you guys did get a bigger number. And again, if you guys showed all your steps and were able to do it, that's great. If you guys weren't able to do it, you guys won't lose so many points. But yeah, that's how. And I saw some of you guys were able to do it on the homework, so I figured that should be fun. Any other questions about this?
Yeah.
Okay. Okay. So I will be going on to the next topic. So for the next part,
Yeah. Professor,
yes.
I was not able to connect very well when you are trying to do certain things. I don't know if you are doing example or the exams.
Oh, right now I just went over an exam question. That was all I did.
The exam question is it 17 pi over 12?
Yeah, that was the one that I went over.
But on my own question, it was 7 pi over 12.
Yeah, no, you guys do not have the same question.
Okay.
Yeah, yeah, that's fine. Yeah.
Okay.
So WebWork actually generates different numbers for you guys. So none of you guys have the same numbers. So
Okay, because that's why I'm surprised that.
yeah, don't worry about it. Yeah.
Okay. Then you said sine pi is 0.
Mm-hmm.
And anytime we multiply that is 0, it will cancel. We don't concern about that side when you multiply 0 with that side. Okay.
Yeah.
And pi 5 over 12, we now split it to 3 pi over 2
Yeah.
pi. Okay.
And then you do it again.
Okay, I will redo it again.
Yeah.
Okay.
Yeah.
Okay.
If you can, so like this one, we know that cosine of pi is -1, but we don't know what cosine of 5 pi over 12 is. So whenever we don't know what this other angle is, we can do it again.
Okay.
So we can do the,
Okay.
and then until we eventually get.
Okay, we will do it as a cos pi 4 and cos pi minus sine pi. Okay. Over 4. Then the one outside, we will multiply it throughout what we are redoing.
Yes, you always want to bring this down because this was, remember that -1 was being multiplied to this whole thing, to the whole thing of cosine. And cosine is actually this whole inside part. So since it's the whole inside part, we're actually multiplying it to this whole thing because these two are the same. So since these two are the same, that -1 should be outside of the whole thing. So you always want to keep that consistent. And so whenever you guys are doing half angles or anything like that, I should point out that you guys can always use whatever angles you want. So you can always use the general angles, which are like 30, 60, 9, 45. I skipped 45. 30, 45, 60, 90, 180, 270, and 360. You guys can use any of these angles. All of these angles should give you the approximate value. I mean, so closer value than this. So all of these numbers you guys can get just by 30, 45, and 60 you can get from your table. 90, 180, 270, and 360 you guys can get just by plugging them into your calculator. So if you guys need to use any of these angles, that's fine. You guys can always use that for your summation and everything. So you know that 30 is just pi over 6. 45 is pi over 4. 60 is pi over 3. 90 is pi over 2. 180 is pi. 270 is 3 pi over 2. And 360 is just 2 pi. So you guys can use all of, yes.
Carry on. I'm sorry.
I'm sorry?
Carry on.
Oh, okay. So yeah, so you guys can always use any of these to find out what your actual value is. So you can either add or subtract any of these values. And again, if you guys have your denominator be 12, the first step that you can always do is change all of these to have the same denominator 12 and see what you can either add or subtract to get your next value. So it doesn't have to necessarily be addition. It can also be subtraction, like the example that we did from the last time. I believe last time we did, where was it? Oh yeah, so like how, for example, how we did 3 pi over 12 minus 2 pi over 12, that's a subtraction to get pi over 12. So you can also subtract.
Professor, so I got
Yes.
19 pi by 12, I think, cos 19 pi by 12.
Okay, yeah.
So I did cos 3 by 2 pi plus pi by 12. And then because I didn't know pi by 12, I did pi by 4 minus pi by 6. And then I got pi by 12, and then I added that to 3 by 2 pi. Would that work? Like a two-step thing?
I can check your work, but yeah. So you can do this multiple different ways. So like, for example, up here, I said that you could also have done it. So 3 pi over 12 minus 2 pi over 12, that is pi over 12, but you could also have done it pi over 4 pi over 12 minus 3 pi over 12, and it still would have given you the same thing. There are multiple ways of doing it. So I'll look over your work and then yeah. And
Sure,
then I'll get,
sure.
yeah. Any other questions about that? I'll give you feedback on the work that you showed. Okay.
I'm okay. I'm okay, Professor. Thank you.
Okay. All right. Okay. So then now we're going to be talking about half angles and double angles. And they're not too bad because, well, I mean, they have formulas. So if you don't like formulas, maybe it depends on how you guys feel about formulas. But these are the formulas for half angles. So these are the half angle formulas. And when we talk about double angles, I'll show you guys the double angle formulas. So half angle formulas are basically a way of finding what the exact value is of an angle that might be half its size. So for example, here you guys have sine of pi over 8. Pi over 8, if you guys notice, there's actually one easy way to determine if it's a half angle. If it's a half angle just by looking at the angle from the inside. If you notice the denominator, this denominator is 8. You can get this denominator to be a multiple of a half. So like, for example, 1/4, pi over 4 times 1/2 is 1/8, because all you have to do is divide these two, multiply these two numbers. So let me put it in simple terms. If you guys can get 2 times a number to get this number, to get the denominator, that means that it's a half angle. So is there a number times 2 that gives you 8? Yes, that's 4. That means that your original angle was pi over 4. So then the half angle that works for, that is the half of pi over 8 is pi over 4. And so that means that you can actually split this up. So you can split this up by writing pi over 4 in the numerator and then divided by 2. So pi over 4 divided by 2 is pi over 8. This is what your angle is. And so that means that if you guys follow this formula up here, that means that your pi over 4 is your alpha. So if pi over 4 is your alpha, then that means that you can just plug everything in. Oops. So you can just plug everything in. And then from there, you guys just have this. So now your alpha, you know that is pi over 4. So this is we're just gonna take this whole square root thing. But you guys notice that there's a little plus or minus sign on the outside here. Whenever you guys have a little plus or minus sign, that basically just means that you have to determine the sign in this quadrant. But what quadrant, if you guys notice that pi over 4 is actually in the first quadrant. And remember that in the first quadrant, sign is positive. So if you guys remember that sign is positive in the first quadrant, that means that here you don't have to worry about the little negative sign. That is just going to be positive because it's in the first quadrant. So the first step that you guys always have to do is identify what quadrant it's in. Okay, fine. Second step. First step, what angle is the half angle coming from? That's your first step. Your second step is to determine what quadrant it's in, to determine if it's positive or negative. And then you can plug everything in and evaluate. So we know that it's 1 minus cosine of alpha. Alpha is pi over 4. You're plugging that in all over 2. And then we just simplify this from here. So 1 minus cosine of pi over 4. We know that cosine of pi over 4, you go to cosine, you go to pi over 4. That's the square root of 2 over 2. So you put that in. And now you're just going to simplify this a bit. So you can multiply everything by 2. That way you get rid of this denominator. So 2 times 1 is 2. The 2's cancel out in the second part. So you have minus the square root of 2. All over 2 times 2 is 4. So this is what you guys get. And you guys can simplify this a little bit. Oh, I didn't. But you guys can. But if you guys don't want to, you guys do not have to. Wait, what did I do? I did not simplify. So this is, let me simplify this. To simplify this, what you guys can do is divide 2 over 4. 2 over 4 is 1/2. So let me just rewrite this. Oh, I know what it was. There's a little 2 missing out here. No, there's not. So yeah, so we can simplify this. This should have been a 4. And then from here, you guys can just simplify this. So if you simplify, what you guys can do is just rewrite this over each other. So remember that this is just the same thing as taking the square root of 2 minus the square root of 2 all over the square root of 4. Because remember that whenever you guys have a whole square root, this is taking the square root of the numerator and the square root of the denominator. So if you guys could take both of the square roots, if you guys take the square root of both numerator and denominator, the square root of 4, you can simplify that down to the square root of 2. And then this stays as the square root of 2 minus the square root of 2. And then that's how you guys can simplify this part. Are there any questions about this? So all you have to do is, again, identify what your half angle is. So what is the angle that they're taking the half of? And then that's going to be your alpha. And then from there, just plug it in. Plug it in and then determine what sign is it in that quadrant. So since this angle is in quadrant 1, we know that that's positive. All right. So let's move on. Oh, any questions?
Professor?
Mm-hmm.
Then anytime we have a pi over 8, we divide that 8 by 2, half.
Yeah. Yep. That's exactly it.
To
So,
do half of the alpha, so that it will be half of the alpha.
mm-hmm. Yeah. So if you can divide this number by 2 and that gives you a nice number, then that's the angle that you guys can use. So pi over 4.
Okay.
Mm-hmm.
Okay, thank you.
So yeah, so if it would have been pi over 16, you guys would have to do it twice. Yes.
Oh, okay. Then do you mean that we have to do it to square root of 2 minus square root of 2? You first of all do pi 8. You finish it like this, then you do another pi 8.
Oh, okay. So if it was, you mean for the square root of 16, right?
Yes.
For sine, if you did have sine pi of 16, then this would have meant that you would have sine of pi over 8 over 2. That means that if you divide pi over 8 by 2, that's the same thing as saying pi over 16. And so this means that you would have to plug this into your formula now. So instead of having pi over 4, now what you're going to plug in is pi over 8. So it's going to be exactly the same thing the same formula as this.
Okay.
So it's going to be exactly the same input. The only thing that's going to be different is that now you're going to have, instead of pi over 4, your alpha is now pi over 8.
Right.
And now, since we don't know we do know now, we would have to evaluate what cosine of pi over, actually, we don't know what this is. We would have to evaluate what cosine of pi over 8 is. Here we found what sine of pi over 8 is, but what we would have to do now is find cosine of pi over 8, so that's this process again. So we have to do this separately on the side.
Okay.
And then whatever we get there, so let's say that this was supposedly our answer, even though it's not. After we get our answer, we would just plug it in.
Okay. Okay.
So cosine of pi over 8, we would do on the side. Whatever we get as our answer, we just plug it into here. That's how you guys do it if you guys have multiple angles. So you guys can always apply half angle, double angles, summation of angles, difference of angles, as many times as you need to.
Okay. Thank you, Professor.
No problem. Okay. So any other questions about this? So yeah, you can always find this separately. And I forgot how to spell. So yeah, so you guys can always do this. And now let's talk about angles, quadrants. And so for quadrants, you guys just have to identify what quadrant it's in. I know some of the homework questions had this. This had trigonometry. This was based off of trigonometry. I'll go over this in case any of you guys have any questions about this, because I think you guys need a review about this. So you guys have sine of alpha over 2 equal to, these are the basic formulas. You guys can use any of these. And if you guys notice, tangent actually has 3 formulas, and that just means that there are just 3 ways of doing this. So does this one. Sorry, I forgot to mention that. So whenever it shows 3 different formulas, they're all equal to each other, so it doesn't matter which one you use. It just depends on what your preference is. So you can use any of them. It doesn't really matter. And then, so let's actually look at this question down here. So these are the formulas that we're going to use. And the question is, given that sine alpha is equal to -5 over 9, with alpha being between 3 pi over 2 and 2 pi, give an exact answer for the following. We have to identify what sine, cosine, and tangent are. And here, all we're going to do is identify what quadrant is this in. So remember that 3 pi over 2 is actually just 270. So that's 270 here. And 2 pi is 360. So that means that it's in between 270 and 360. That means that it's in the 4th quadrant. So that's what this means. It looks a little weird. It looks a little complicated, but this is just telling you that this angle, alpha is the angle. The angle alpha is in quadrant 4. That's all it's trying to say. And then from here, we're just gonna literally just do everything as before. So if your alpha is in quadrant 4, if you take any of these angles and divide them in half, remember that alpha is being divided in half. So take 360, divide that in half. What do you get? You're gonna get something you're gonna get 180. And now take 270, divide that in half. If you divide 270 in half, what do you guys get? You guys can use your calculator.
135.
Yes. So 270 divided in half is 135. So you guys have, it's going to end up around somewhere around here. So that means that any angle that is between 270 and 360, if you divide that in half, that's going to end up somewhere in this region here. That region is in quadrant 2. So any half angle that is between 270 and 360 will end up in this 2nd quadrant. So you know that this alpha over 2 is in quadrant 2. Now that we have identified that, that tells us whether our sign is positive or negative. And now we just have to identify, is sign positive or negative in the second quadrant? You know that sign is positive. So this should be the top option, which is positive. And now from here, we can just take everything and plug everything in. Hold on, sorry. Now let's take this information. Okay, so we have identified what quadrant it's in, but now let's actually find out some information about alpha. So we have sine alpha is equal to -5/9. That's the given information, right? And we know that sine is equal to opposite over hypotenuse. So let's actually draw a triangle here on our axis. If we draw our triangle, remember that all triangles are based off of these triangles here. Let me erase some of this. You guys are either going to get some sort of triangle like this. It's either going to look like, depending on what quadrant it's in, you guys should remember this bow tie. I think some of you guys have seen this as part of trigonometry. This bow tie basically tells you how the triangle is going to look like in each quadrant. So in this first quadrant, if it's in the first quadrant, it's going to look like this triangle. In the second quadrant, it looks like this. Third quadrant, it looks like this. Fourth quadrant, it looks like this. It's basically the triangle that's closest to the x-axis. Remember that you're always going to try to look for the reference angle, so that reference angle is going to be close to the x-axis. That's where these triangles are coming from. They're coming from your reference angle. So this angle down here, this is the reference angle. So this is the angle that you're looking for. And so since this is in quadrant 4, we're actually looking at this specific triangle. This specific triangle, so let's draw that down here. That means that we're looking at this triangle here. And opposite over hypotenuse, that means that this is our opposite side. So remember that this is our angle. The angle that we always look at is the one that's closest to the x-axis. So opposite this angle is this side here. So this is our -5, and our hypotenuse is 9. So we can label that. And then a way to determine what your sides of your triangle are is just by looking at these axes. So here, you guys know that the lower part of the axis, the lower part of the y-axis is negative. So that means that this side is going to be negative. On this side here, on this part of the x-axis, you guys know that this part of the x-axis is positive. So that means that this side is going to be positive. And then the hypotenuse is always going to be positive because you're doing the Pythagorean theorem, which squares everything, so it makes it positive. So whenever you guys have something like this, you know that the hypotenuse will always be positive. But now that we have this, one way to identify everything, one way to identify the side is just by using the Pythagorean theorem. So we can take a squared, which is what we're looking for technically, plus b squared, which is -5, equal to 9 squared. So you just simplify this, -5 squared, 25, 9 squared, 81. We can subtract 25 to both sides. You can subtract 25 to both sides, and then that just gives you the square root. That gives you a squared equal to 56. So you can take the square root of both sides, and that gives you the square, that a is equal to the square root of 56. So that's how you can get this point. And then from here, what we actually need in order to find this is cosine. So that's the reason why we had to do all of this, because we need to identify what cosine is. Since we need to identify what cosine is, we can easily do that just by finding what adjacent is. Remember that cosine is adjacent over hypotenuse, so that's just the square root of 56 over 9. And then you guys can do the same thing with tangent. I'm going to need tangent for a little while later, so I'm just going to say that right now. So tangent is also going to be adjacent over hypotenuse. So adjacent over hypotenuse, that's the square root of 56. Sorry, it's opposite over adjacent, so that's -5 over the square root of 56. So that's what tangent is. So opposite over adjacent, that's -5 over the square root of 56. And then from here, all you guys have to do is just take in the information that you need depending on what formula you're using. So since we're looking for, I keep scrolling up and down. Let me keep it consistent. Okay. So since we are looking for the half angle, we're using this formula. This means that we need to know what cosine is, and that is what we found already. So we're just going to plug everything in. So we're going to have 1 minus cosine of alpha. Our cosine of alpha was a square root of 56 over 9, all over 2. So that's it. That's all we have to do. That's how we can find the half angle. So this is the exact value for the half angle. And if you guys want to simplify this a little bit, you guys can do that. I chose to not simplify it for this example just because I had to do 3 of them. But you guys can do simplifying, and that's exactly the same way as you guys would simplify these. You can just multiply it by the denominator, and then that will get rid of that. So in this case, you can just multiply everything by 9, and then that will simplify it down. Will the y-axis in quadrant 4 be negative, or is it because sine was negative 5 over 9? So the axis always tells you the sign of the side, and it actually makes sense. So it's negative 5 because of this quadrant. So it is because of both terms. It is because it came from negative 5. It is because it came from the original given. It came from here, but it also is because of the axis. So since we know that it is in quadrant 4, the opposite side in this quadrant has to be negative because of the axis. So they both go with each other. So it's negative from the given and because of the axis, because it's negative on the axis. Can we use sine squared alpha plus cosine alpha instead of the triangle? There are different ways of doing this. So if you guys know of a different way, and you guys are able to find the correct answer, honestly, I have not seen it with sine squared alpha plus cosine squared alpha, but
It works. I just tried it now.
Okay, yeah.
Yeah,
So
I just
I
tried
haven't
it.
done, yeah, no problem. Yeah, I haven't done it that way. But if you guys do get the same answer, then that's great, and I will look over your work if you guys need me to. And then I'll let you guys know if that works or not. And then yeah. But if it works, so Arian just confirmed that he got the same answer. So you can use sine squared alpha plus cosine squared alpha for now. If you choose to do it that way. But again, if you guys want to use the formulas, you guys can also use that. Or set up your triangles. Again, it's math. You guys can do this in multiple ways. Any other questions? Okay. So then now you guys are just going to do cosine of alpha over 2. So cosine of alpha over 2, that's just going to mean that you are plugging this, using this as your formula now. And then remember that your alpha over 2 is in quadrant 2. Since this angle is in quadrant 2, cosine is negative because only sine is positive. So this has to be you're using the negative sign for cosine. And then now you're just again plugging it in. So you're using 1 plus cosine alpha. Cosine was the square root of 56 over 9. And then this is all over 2. So this is your answer. And then for tangent, same thing. So for tangent, remember that we can use any of these 3 formulas. Pick one, and then that's the one that you can use. I chose to use this middle one. I chose to use sine of alpha over 1 plus cosine of alpha. So we know that sine is negative. We know that sine is negative 5 over 9. That's this part. So I'm just filling it in. Plus, and then cosine of alpha is the square root of 56 over 9. So that's how you guys can get this. It's literally just plugging things in and finding your answer. Any questions about this? Okay. So just like you guys can find the double angles, sorry, the half angles, we can also find the double angles. So this is in case you wanted to find double of an angle. And I'm actually going to use the same example to find the double angles for these. So if you guys think about it now, if you guys double this, so this actually, if you guys notice, there actually is no sign difference. There is no plus or minus sign in these formulas. So since it doesn't matter what your sign is, then you don't have to worry about what quadrant it lies in. You can just use this formula directly. The only one that you will have to worry about the sign is the half angles. So for the half angles, that's when you will have to determine what your sign is for sine, cosine, and if you choose to use this last formula. I use this middle formula, so I didn't have to worry about the positive or negative sign. But for cosine and sine, you will have to worry about that. Just be careful of that. So one question is all of the material we're going over also going to be on the final? The final is going to, I'll actually post a final review sheet today of what you guys can expect for the final. And then the final review sheet is something you guys should get started on. I'll actually announce this now since it came up. So what I'm actually trying to do is I will actually, so I know some of you guys have had an exam where you probably didn't do as great as you would have wanted to. So because of that, I am actually going to give you guys an optional 4th exam, which means that you guys do not have to take it if you guys do not want to. If you guys do want to take it, you guys can take it, and then that will actually drop your lowest grade on your exam. So if you guys choose to take the 4th exam that I will assign, it's also going to be on Sunday, just like the regular. That will actually drop one of your lowest previous grades. If it came out to be something that you didn't like, then I'll just take the top 3. Basically, the top 3 of whatever your exam grades are. So that will count as that. But the exception of that is that since it's so close to the final, what I'm actually going to do is I'm kind of going to make that also as a review kind of thing. So that's actually going to be covering the material that we learned throughout the week, plus some of the things as a review from the previous weeks. So it's kind of like that's going to be the change off. So it's going to cover this week's plus a couple of things from the previous week. That way you guys get some sort of review out of that. And so that again will drop your lowest grade. And that is optional. So if you guys want to take it, you guys can take it. If you guys don't want to take it, if you you don't have to take it. But yeah. Let's turn it off. Are there questions about that? Okay. Can we take it as a practice test? You can definitely take it as a practice test, yes. You guys, so if you guys can just take the test if you guys want it for practice. It doesn't have to necessarily mean that you guys are gonna, if you guys choose to take it, you guys can definitely take it. It's completely optional. If you guys want to do it for practice just to see how you guys do, that is also great. I haven't, when is it available? It's gonna be the same as every other test. It's gonna be on Sunday. I'm gonna have it available from starting Sunday 12 a.m., which is technically the night of Saturday up until 6 a.m. That's the last time that you guys can take it. And it's going to follow the same rules as any other test. So right afterwards, you're going to submit your work on Blackboard. And so submit your work as soon as you guys are done, and then I will grade that. And I haven't gotten any news yet about your final exam, unfortunately. I'm not sure exactly how they're going to run that, but like I told you guys last time, there were practice exams that were available. I don't know if they're going to do that or not this time. I haven't gotten any notice of that. Maybe I'll get some information during the week this week, since next week is your final week. But I haven't gotten any news yet. But if you guys choose to take it, you guys can definitely take it as practice. And then that's how you guys can do that. But If there are no other questions, I will carry on. And then if you guys think of a question, you guys can also just ask it in the chat and then I'll answer it. Okay, so now let's talk about double angles. Double angles are actually the same thing. Again, you're just using the formula. And then that's how you guys can identify each of these. Let me just, okay. So now let's talk about double angles. And then, so if we're trying to find sine of 2 alpha, which is the double angle of alpha, we're just going to use this formula here. So we need to know what sine is and we need to know what cosine is. Previously, we had already found it. We already know that sine of alpha is negative 5 over 9, and cosine of alpha is the square root of 56 over 9. So we're just going to use this and plug this in. So we're going to have 2 times both of these things. So we can just simplify this by multiplying 2 times negative 5. 2 times negative 5 is negative 10 times the square root of 56. That's the square root of 56. And then this is all going to be all over 9 times 9. That's 81. So we're just going to simplify this a little bit. And then one way of simplifying this would be by simplifying the square root of 56. If you guys take the square root of 56, you guys can simplify this by breaking it up. Remember that to break up a square root, all you have to think of is a number, a perfect square that goes into 56. So 2 numbers that multiply to give you 56, where one of them is a perfect square. That's what you guys have to think about. And one of those numbers is 4. And remember that a perfect square is just like 4, because 2 times 2 is 4, so 4 is a perfect square. 3 times 3 is 9, so 9 is a perfect square. 4 times 4 is 16, so 16 is a perfect square. Those are the perfect squares. So you have 25, 36, 49, and it keeps going. So you have 2 times 14. And then the square root of 4 is 2. Square root of 14, you can't simplify that, so that stays the square root of 14. And then you go over here. We're just going to plug this in. So instead of writing the square root of 56, we're going to write 2 square root of 14. And now we can multiply negative 10 times 2, that's negative 20, square root of 14, all over 81. And that's it. This is our answer. We can't simplify these because there are no greatest common factors. There are no factors between 20 and 81 that go into each other. So this is as far as you guys can go. Are there any questions about this? Literally just take our information and plug it in. Okay. So now for the next one, we're going to do the same thing. So I chose to use this. Again, you guys have multiple formulas that you guys can use. You guys can use this one, or this one. It doesn't matter. You guys will get the same thing. I chose to use the one that looks similar to the trigonometric identity, but it has a subtraction sign. So here you guys have cosine squared minus sine squared alpha. So all I'm going to do is I'm going to take my sine, square that, take my cosine alpha, square that, and then get my answer. So remember that whenever you have square on the outside, you're squaring both the numerator and denominator. So the square root of 56 squared is just 56. 9 squared is 81 minus negative 5 squared, that's positive 25. 9 squared, that's 81. So you just subtract these. 56 minus 25, that's 31. And you keep the denominator the same, so that's all over 81. And that's it. And then for this tangent, what I'm going to do is I'm going to use the tangent formula. So that's 2. I have that here. So that's 2 times tangent all over 1 times tangent squared. And remember, we already found tangent. So we're just going to use that. So we're going to 2 times tangent, that's negative 5 over 50, square root of 56, all over 1 minus negative 5 all over the square root of 56 squared. Since this is being squared, this goes on the outside of tangent. And now you just simplify this. So you guys can multiply 2 times negative 5. 2 times negative 5 is negative 10 over the square root of 56, all over 1 minus negative 5 squared. Negative 5 squared is 25. The square root root of 56 squared is just 56. So you guys end up getting this this part here. If you guys want to simplify this completely, as much as you guys can, then what you guys can do is multiply. This is again a complex fraction, so you guys can multiply them by the LCD, which is the least common denominator. So the least common denominator here is 56 times the square root of 56. These two are not the same thing, because remember that this is on the outside of the square root, this is on the inside of the square root. They give you two different values. If you guys take the square root of 56, that gives you 7.48331, and that's not the same thing as 56. So these two are completely different numbers. So that is the LCD, and then you multiply to everything, you cancel things out. So in this numerator, if you simplify, the square roots cancel out, so you're left with negative 10 times 56, that's negative 560. Here in this one, nothing cancels out, so you're just left with 56 times the square root of 56, because that times 1 is itself. And then here, the 56 is canceled out, so you're left with minus 25 square root of 56. So you can simplify by subtracting these two. Since they have the same thing, the same square root on the inside, you can subtract the outside. So you can subtract 56 minus 25, that is 31, and then the square root stays the same. So that's how you guys can subtract this. I'm going over this kind of like as a review for square roots. So you can subtract them only if they are the same on the inside, and then that's 31 square root of 56, and then the numerator stays the same. And then remember that if you want to rationalize this, you can multiply it by itself. So the square root of 56 multiplied to the numerator and denominator, and then just simplify it out. So this is going to be negative 560 times the square root of 56 all over 31 times 56. And then here, if you guys notice, you guys can simplify 56 and 56 in a way that these kind of cancel out each other, but there's still a 0 left. So you just replace that with a 1 and a 0. You can also just divide this in your calculator. 560 divided by 56 is 10, negative 10. So that's how that simplifies out. So you have negative 10 square root of 56 all over 31. So this is your final answer here. And that's it. That's as far as you can simplify. Are there any questions? All right. So, your turn. Okay, now you guys are going to practice. So you guys are going to do the half angles. So you guys are going to find the half angles and double angles given this information. And that's how you guys can practice. Oh, let me actually go up and pull those formulas up for you guys. So this is the double angle. Copy. So you guys can start working on these. These are the double angle formulas. And then let me go get the half angle formulas. So these are the formulas that you guys can use to find these. And then you guys can share your work once you guys are done. Tutoring for this topic is usually from, I send out a flyer. I can't recall it off the top of my head, but I think it's every day. I don't know if it includes Friday. I know it's Monday through Thursday for sure. I'm not sure about Friday. Give me 1 second. I'll double check right now. So you guys can work on this while I look this up. Okay, so tutoring is available on Monday through Thursday from 10 a.m. to 7 p.m. on Mondays and Wednesdays, and then from 10 a.m. to 6 p.m. on Tuesdays and Thursdays. So you guys have all day basically up until 7 or 6 p.m. And then I sent out a link I sent out the flyer for the tutoring session. I can resend that if you guys need me to, but that has the code, the link, the Zoom link that you guys can join. That's how you guys can get there. Okay. So yeah, so basically all you have to do is just plug everything in. But okay, so you know that it is in the fourth triangle, the fourth angle, in the fourth quadrant. So you used the Pythagorean identity, the Pythagorean theorem. And so you basically did, I can see that you did that by just plugging in your -3 and your 5. And this can also, so if you guys want to do this way, this is fine. And then you guys can also draw your triangle if you need to. So the triangle, if you need to, you know that you're given that sine is sine theta, sine alpha, it's the same thing. So your sine is basically, what was it? Negative 3/5. So this is equal to -3/5. So if you want to draw out your triangle, you can draw it in the third quadrant since that's where it is. And then that basically means that you have -3. So this is your angle. Opposite is -3/5. Hypotenuse, which is 5. And then you can find this angle by using the Pythagorean theorem. And then using the Pythagorean theorem, all you have to do is just do 25. 5 squared is 25. And then -3 squared is 9. So that's how you get that. So you get 25 minus 9 is 16, equal to x squared. And then you can take the square root of both sides. The square root of 16 is 4. That means that this missing side over here was 4. And now you can basically just plug everything in. So you know that sine is going to depend on that. So just one tiny note. Whenever you guys are finding sine, cosine, and everything, just write whatever you guys are looking for. So this would be sine over 2, alpha over 2. So this is what it's equal to, because then it's kind of confusing to the reader, because they're all sine, cosine, tangent, and then sine, cosine, tangent. So just specify whether it's the half angle or double angle. And then this is, I think you have the negative, yes. So then this is negative. And let me just go over how to get this negative sign again. So for the negative sign, depending on wherever your angle is, so remember that your angle in this case is in the third quadrant. Since it's in the third quadrant, you guys have all your angles between either 180 or 270. So you can basically think about, okay, fine, let's split this in half. Let's split up 270 in half. 270 in half is going to be around, it's going to be, 270 in half is like 135, and then 180 in half is 90. So all of these angles are going to fall into somewhere around this region here. They're going to fall somewhere into the second quadrant. So that means that you're going to still have all of these angles in the second quadrant. So in the second quadrant, you know that sine is positive, cosine is negative, and tangent is negative. So those should be your signs. So that's how you guys can determine whether it's positive or negative. So this should actually be positive sign. Oh, wait. Yeah, sorry. Yes. So it's positive in the second quadrant. So that's how you guys can determine that. And then from there, you guys can just proceed from there. And then you just plug everything in. Are there any questions about how I got the sign? Questions? Comments? Concerns? In the first problem, how did it become 1/5? Okay, I haven't gotten to that part yet, but so you basically get to 1/5 by just plugging it into the formula. So you know that the formula, you guys have the formula. I did not pull that up yet. Let me see. You guys have the formula on your screen currently, and that is, oh, maybe you don't have it on your screen, but it's on the notes. And then the formula is basically just the square root of 1 minus cosine alpha over 2. Let me write that down here. Square root of 1 minus cosine alpha over 2. So this is the formula. Yeah, okay, great. So then this is the formula, and all you have to do is plug in whatever cosine is. So cosine, we know that it is adjacent over hypotenuse. So that means that cosine of alpha is equal to, adjacent is 4, and then your hypotenuse is 5, so you can just plug that in. So that's 1 plus, so then that's just 1 minus 4/5, and then 1 minus 4/5, if you want to get the 1 with the same denominator to subtract, all you can do is basically just rewrite this over 1, and you have to have the same denominators. So the denominator here is 5, so we need to multiply 5 to both numerator and denominator, and that turns into 5/5 minus 4/5, and then this is equal to 1/5. So that's how you guys can do that. And then from there, you just simplify it. So you can just simplify this, and then this would mean that you have to do keep, change, flip. So you keep this same, you keep 1/5 the same, you change division to multiplication, and then you flip the second fraction. So that would be 2/1, and then, 1/2. This is over 1, and then this is over 2. So you flip the second fraction, so that becomes a 1/2, and then you're left with 1/10. So this would be positive, the square root of 1/10. Would 4 on the x-axis be negative? Yes. It would be negative on the x-axis.
Yeah, Professor.
Yes.
Do we have the formula as plus or minus square root 1 minus cos alpha over 2. Since we know that the sine half of the angle sine is in third quadrant, then we have to take the negative part of the outside, plus or minus. That plus or minus that is in the formula. Do we have to take in negative because we have plus or minus?
Yeah, so it depends on whatever quadrant you're in.
Okay.
So based on the quadrant, so in this case, all of our angles are falling into the second quadrant. So because they're falling into the second quadrant, that means that sine is positive in the second quadrant. So you don't have to worry about it being negative.
Oh, okay.
So that
How do we know that our angle first fall to the second quadrant?
so we know from the given, we know that that our angle is in quadrant 3.
Yes.
So we know that it is in quadrant 3. That means that it is in this area. So that's what I kind of went over. It's in this region here.
Yes.
So in this region, if you divide 270 in half, that's 135. If you divide 180 in half, that's 90. So it's going to fall somewhere in this region here.
Okay.
Somewhere in the second quadrant. So that must mean that it's going to end up in the second quadrant, and then from there, oh wait, can you guys see that? Okay, so yeah, so you guys can see that. So that's how it's going to end up. And then so because it's in second quadrant, that's that just means that sine is positive in the second quadrant, so you don't have to worry about it being negative. And yes, so 4 is negative in the second quadrant. So this is going to be negative. So because it's negative, this actually switches to a little plus sign, because a negative times a negative is a positive. So that actually means that we're adding 5/5 plus 4/5. So that's 6/5. And then that would mean that this is 6/5 times 1/2. And then that is
It's absolutely, yes, the sine is the square root of 9/10, and the cosine is square root of 1/10.
I'm confused, Professor.
okay. What are you confused about?
Hello, Professor.
Yes. Can you hear me?
Yeah, I'm confused now that we know that you said the sign is in the third quadrant, and in the third quadrant the sign is negative.
Yes, but this sign up here, so over here you guys have the Pythagorean theorem that depends on the triangle. So since this is in the third quadrant, you guys have your identities. On the x-axis, this x-axis is negative, and this y-axis is also negative. So because your triangle is in the third quadrant, your opposite side is going to be negative, and so is your adjacent side.
Okay.
Because of the x-axis and because of the y-axis.
Okay.
So then based off of that information,
is that why we change this to positive?
Yes.
The plus 4.
Yes, because the formula for sine is 1 minus cosine.
Yes.
So a negative times a negative is a positive.
Okay.
Mhm. So yeah, so just
That
be
means
careful
we
with
have
the
to
sign.
be, yeah, we have to be careful about the axis and the x-axis and y-axis,
Yeah, yeah.
where those things fall. And the
Yes,
left side is negative, the right side is positive.
yes,
The x-axis, and both the same thing with the y-axis. The top
yeah,
is positive,
yes. So you always have to be careful with those.
Hmm.
It's a little easy to forget them sometimes because you're so used to just going through the process. But with these, you have to double check your signs constantly. So just double check your signs with everything. And then from here, but once you figure out what your actual angle is, so what your actual sides are, so once you determine if it's positive or negative, based off of your triangle or based off of the Pythagorean of the identity, trigonometric identity, cosine squared, then that'll be the same thing. Why is it 6/5? So it's 6/5 because of the, so this was actually negative 4
It
over,
should be not 6. It should be 9/5. It's 5 plus 4.
oh, sorry, thank you. Thank you. I didn't read my numbers correctly. So yeah, so you add 5/5 plus 4/5, and that's 9/5. And then 9/5 times 1/2, that is 9/10. So this should really be 9/10 over here. And so that's positive square root of 9/10. So that's the answer that you guys should have gotten. Are there questions about this?
The cosine is also not correct. It should be 1/10.
Yeah. I was just asking about sine first, before I move on to the cosine part. But yes, you're right. Okay. So for the cosine, it's exactly the same thing. All you're going to want to do is, again, just plug it in. So for this part, since cosine is negative, we have negative 4/5, because cosine of alpha is equal to negative 4/5. So you're going to plug that in. So that's going to be 1 plus negative 4/5 over 2. And then from there, you just have to do the operations. So in this case, you're subtracting. So 1 minus 4/5, we had actually already done that before. That's actually going to be 1/5. And in this case, it is negative. So this is correct. So it is negative. And then from here, you just have to do 1/5 divided by 2. And then in that case, that is the 1/10. So questions about this one? I think WebWork will accept this one. I won't really ask you guys to simplify this too much. Once you guys have evaluated this, I'll consider that as full. But if you guys want to simplify it completely, I will also accept that. So you guys can continue to simplify this. If you guys continue to simplify this, this would just be the square root of 1. The square root of 1/10 basically is the square root of 1 over the square root of 10 with a negative outside. And then here, you guys know that you can't have a square root in the denominator, so you can multiply this by the square root of 10 and multiply this by the square root of 10, so numerator and denominator. So this turns into negative square root of 10 all over 10. So that's how you guys can rationalize. And then that's it. And then for tangent, it's exactly the same thing. For tangent, you're just going to plug this into the formula. So you're plugging in, I can't see the formula. Give me 1 second. The formula is sine alpha over 1 plus cosine. So cosine, we said that was negative. So this is going to be negative 4 over 5 over negative. So we have negative 3 over 5 over 1 plus negative 4 over 5. And then now we're just doing the addition. So 1 plus negative 4 over 5. We had done that before. So that's just 9 over 5. No, it's not. Wait, hold on. That's just 1 over 5. And then you have negative 3 over 5 divided by 1 over 5. So you're doing the keep, change, flip. So that's actually, so if you do the keep, change, flip, I'm going to do that on the side. That way everyone can see it. So you have negative 3 over 5. You're going to change division to multiplication, and then you're going to flip your 5 over 1. So the 5's cancel out, and this is actually equal to negative 3. So this is going to be equal to only negative 3. It looks like I canceled it. So that's negative 3. And that's how you can get that. Are there questions about tangent? Okay. And then for alpha, for sine of alpha, you're doing the exact same thing. So you're just plugging it in. So you're plugging in sine and cosine. So we have negative, so we have 2 times negative 3 over 5 times negative 4 over 5. So we have to multiply negative 3 times negative 4 times 2. So negative 3 times 4, that's negative 3 times negative 4 is positive 12. Positive 12 times 2 is 24 all over 5 times 5, which is 25. So that's how you get sine of alpha. And then cosine, same thing. You're just plugging it into the formula. So you're plugging in negative 4 over 5 squared, but that doesn't change anything because it's going to turn positive either way. And then that's going to be 16 over 25 because you're squaring 4 times 4 is 16. 5 times 5 is 25. And then here you're squaring negative 3 squared. That's 9. 5 squared. That's 25. And now you're just subtracting. 16 minus 9 is 7 over 25. So this is what your answer should be. Let me erase my little box. And then for tangent, it's the same thing. For tangent, you just have to plug this into the formula. So you're plugging in 2 times negative 3 over 4 to all over 1 minus negative 3 over 4 squared. So if you plug this in, you're plugging 2 times negative 3, that's negative 6. And then negative 6 over 4. And then you're just doing negative 3 squared, that's 9. 4 squared, that's 16. So you're doing 1 minus 9 over 16. So again, you're just turning the 1 to have the same denominator. So that's just 16 over 16 minus 9 over 16. And then you can subtract 16 minus 9. 16 minus 9 is 7. So that's 7 over 16. And then you do keep, change, flip. If you guys need me to do that, you guys would do negative 6 over 4. You change the multiplication. You change the division to multiplication, and then you flip 16 over 7. And then you just do this normally. So you can you can multiply across or simplify first, whichever you choose. If you multiply across, you would get negative 6 times 16, which is 96. You guys can also double check on your calculator if you need to. So negative 6 times 96 times 16. And that's how you guys can get that. So it's the same thing, over 28. And then you guys can see that it's the same thing. So then you just reduce. Whenever you're reducing, this is something that you guys can always check. If you guys aren't sure, whatever, if a number goes into something, you guys can observe if both of the numbers are even. So here in the numerator, you guys have an even number over an even number. If they are both even, what you can always do is divide both numerator and denominator by 2. If you divide both of them by 2, that can actually simplify it. But that is only if you cannot find something that is bigger. That's if you're stuck and you're like, wait, what goes into this? So that's how you guys can identify it. But you just have to basically look for the GCF. You can actually divide this by, the greatest common factor of this is actually 4. So we can divide both of these by 4. And so if you chose to do 2, you can do it 2 times. But the GCF was actually 4, the greatest common factor. So if you divide 4 to both the numerator and denominator, you would get negative 24 over 7. Are there any questions?
I have a question.
Yes.
Should not be tangent positive 3 over 4 and not negative 3 over 4? Like the tangent of the in the beginning.
I didn't check the formula. Give me 1 second. Okay, so the formula is asking for tangent, and then that is going to be, so tangent according to our problem is, tangent is negative, so that's opposite over adjacent. Opposite is negative 3 over negative 4, which is positive 3 over 4. Yes.
So at the end, it's going to be positive 24 over 7, right?
Yes. Sorry. I go along with, sometimes I do not double check your answers, which I should not do. Let me just go through everything and not get ups with your work. Okay, but it's good that you guys are checking everything. So over here, you guys have to have positive 3 over 4. And then here you guys have positive 3 over 4. And then this is going to be 6 over 4 all over 1 minus 3 squared is still 9, 4 squared is still 16. And then you just have to do 16 minus 9. 16 minus 9, this is 6 over 4. Can I skip steps? No. Okay. All over, give me 1 second. I ran out of room here. All over, there's going to be 7 over 16, and then you're going to do keep, change, flip. So you're going to do 6 over 4 times 16 over 7, and then you're just going to simplify this. So this is going to be 16 times 9, 16 times 6, that's 96 over 28. So it's the same thing. All you just have to do is just keep it as positive 24 over 7. Are there questions? How's the best answer positive? Positive, positive, positive. First answer. It's positive because first answer. Okay. Okay. So that one's positive just because you're just plugging it into the formula. So over here you guys had that this one was negative. So it was sine times cosine. Sine was negative sine was negative 3 over 5, and then cosine was negative 4 over 5. Negative times a negative is a positive. So that's how you guys can do that.
I have a question about alpha over 2 about the sine of sine and cosine. So does it stay the same as for alpha or no? For the sine alpha over 2, does the sine of, I mean, is it plus or minus? Does it stay the same as it was for sine of alpha in the beginning, or no? I'm confused with that.
So alpha depends on what quadrant it's in. So it depends, we don't actually know what alpha is. So depending on whatever quadrant it's in, that is based off of that. So the alpha, so before we had earlier identified what tangent is. So we identified what tangent is, we identified what cosine is, and we know that sine is equal to this. So this is all information that we have determined. And then from this, we can take this information and plug it in. But if we don't have this information and it's something like the first question, the very first question that I talked about, where they actually gave us the angle, then we can determine whether it's positive or negative depending on taking the half of that angle and seeing what quadrant it lies in.
Yeah, the thing that I'm asking is for the half angle. So, for example, here I cannot find out in what quadrant the half angle is. Does it have the same sign as the full angle? They're just saying that the sine of alpha is -3/5, and then the half angle, what's going to be positive or negative? And I can see that the sine is positive and the of half angle is positive and the cosine is negative, but I can understand why.
You mean in these, right?
Yeah.
Okay. So yeah. So because because it is in the, we know that our angle is in quadrant 3, right? Our original alpha is in quadrant 3.
Yeah.
So then because our original alpha is in quadrant 3, that must mean that any angle is between 270 degrees and 180 degrees. So it's all between this area.
Yeah.
And then if we split up 270 in half, 270 in half is just 135. So that's going to fall somewhere in this region. And then 180 in half is 90. So that's going to fall. So any angle between this region is going to end up in the second quadrant here.
Okay.
So that's how you guys can identify where your angle is going to end up. And then that means that any angle that gets split in half is going to end up in the second quadrant. So based off of that, since it is in the second quadrant, you know that sine is going to be positive, but everything else is going to be negative.
Okay, thank you.
No problem.
Professor.
Yes.
Putting all this value because it's a square is complicated. What are the best way in order not to confuse with the signs?
Okay,
of
so I'll give you guys a
positive and
list of
negative?
stuff that you guys
So that because it's more or less putting everything and it gets confusing.
Okay, so this is how you guys can do this. So the very first thing that you guys should always do, so that way you guys do not get confused with the signs and everything, is first, so these are a couple of things that you guys can check. So you guys should definitely check your angle. So if they tell you what quadrant it's in, so this is actually, so we know that this is in quadrant 3. Since we know that you have your quadrant in quadrant 3, you have to look for where is your half angle. So you have to look for where is the half angle. So that's the first thing that you guys have to look for what quadrant is it in. And then after that, that will determine the sign of your cosine, sine, and tangent. That determines the sign of those. And then once you have that, you can draw your triangle or do the Pythagorean identities, which I haven't taken a look at, so I'm not sure. I haven't taken a look at how you guys do that, but I will take a look at it after. So you guys can draw your triangle and then identify, and then you're gonna label the sides based off of positive or negative on the axis. And then from there, you should have your, so then that means that you're going to have your cosine, tangent, and sine. I ran out of space, but that's basically the fourth step. So the fourth step is to identify. So find sine, cosine, and tangent. I ran out of space. But basically find all three of those, and then just make sure of your signs here first. And then once you guys are 100% sure about your signs in this part, then everything else is just plugging everything in. So once you guys have identified this, in these four things, then you guys can move on to just plugging everything in without worrying about the signs. Unless it has a minus and a minus, then you just change that, because a negative times a negative is a positive. So you just change that to whatever it is. That's called simplifying, though. That's part of simplifying.
Thank you, Professor.
No problem.
Yeah. Do we have another example you can give to us so that
For this one?
Yeah, so that
I
we
only
can use
that,
the practice, another practice ones that.
Yeah, you guys have homework on this. So this your homework problems are just like this.
Okay.
Yeah, that's why I chose to do a question like this. So your homework problems are exactly like this. I think there's only 2 of these questions, but you guys can click the show me another button and then it'll give you another question that's similar to this. Are there any other questions about this? Okay. So then now let me go on to the next part. And we're actually going to be talking about solving trig functions now. Trig equations. Trig equations are similar to solving regular equations. Let me stop sharing this so that I can. Yeah. Okay. So to solve a trig, oh, did anyone have a question? I kind of heard something. I will take that as a no. Okay. So whenever you guys want to solve for trig equations, all you really have to, there's a list of steps that you guys can do, but to find out what your trig equations are, I know some of you guys have solved trig equations in the past as a part of trigonometry, but you guys have only solved for the general, for the solutions where it is from 0 to 360 degrees. So that's only some of them, but there's actually a lot more solutions, and that's because you can go around the circle a whole bunch of times. But let me first go over this part. So whenever you guys are solving for an equation, you guys can always solve for x by the x, anything inside the parentheses, anything inside the function of sine, cosine, or tangent, that's always your angle. So this x, and this theta, this is called theta, these are actually your angles. So whenever you want to solve for the inside, whenever you're solving for the angle, you can always use the inverse of trigonometry. So on your calculator, you guys notice that there is a little inverse button on top of whatever sine, cosine, or tangent is. That's actually used for whenever you guys want to find the angle. So let's say that we have sine of x equal to the square root of 3 over 2. So then if we use the sine inverse, that's actually getting rid of sine on this side. So we're left with x is equal to, and then on this side, we're going to have sine inverse of the square root of 3 over 2. There's 2 ways that you guys can do this. You can either go to your table and say, okay, I'm on sine 3 over 2. Okay, so the angle that it corresponds to is 60 degrees. So that's how you guys can get that. Or just go to your calculator. Your calculator also tells you this exact thing. And in order for it to give you something nice, click on degrees. So you always want to go to mode and then go to degree and hit enter. And then you guys can click on second, sine, and then type in the square root of 3 over 2. And then just remember to hit that little arrow so that it gets out of the inside of the square root or close your parentheses. And then once you plug this in, this gives you 60. So you guys get that your x is actually 60 degrees. So again, just whenever you guys want to find what the
Professor,
the inverse, yes.
would that be the only value? Like, wouldn't there be more values where
There are more
sine
values,
inverse
yes.
is 3?
Yes, we will talk about that. I just wanted you guys to be introduced to this part first, and then I'll talk about that in a minute. But yes, you're correct. There are multiple.
Oh, okay.
Yeah.
Thank you.
No problem. That's what we're going to be talking about now. And so if you wanted to turn this into radians, again, remember that 60 degrees is just the same thing as pi over 3. So that's how you guys can get that. And then another example is that if you wanted to, I actually did 3 of them. So you guys, if you wanted to find the tangent x of the square root of 3, then it's the same thing. You guys are basically looking for the angle that has tangent equal to the square root of 3. So again, just to solve for both sides, you can take the inverse of both sides. So you guys get that x is equal to tangent inverse of the square root of 3. So all you're literally doing is just taking tangent inverse of whatever's on the other side, and then that tells you the angle. You guys can either look here, so you have tangent square root of 3, and that's 60. Or again, just go to your calculator, type in second tangent, and then square root of 3, and then that still gives you 60. 60 is pi over 3, so that's how you can do that. And then cosine of theta equal to the square root of 2 over 2. Again, same thing. You can also go to your calculator, type in cosine inverse of the square root of 2 over 2 over 2, and then that gives you 45. So that gives you 45 degrees, and you can again just determine that from your table again. If you're trying to see what gives you square root of 2 over 2, well, that's 45 degrees. So that's pi over 4. And so that's essentially how you guys can do this. You guys can find the angle for this. This is just finding one angle. Are there questions about this part? Okay. So now we're going to talk about solving trigonometric equations. There are actually a list of steps that are right here. So here, there are ways of solving for this through a list of steps. So the first step that you would always want to do is solve for. So you're basically going to want to solve for the trigonometric function first. So you want to isolate the trigonometric function on itself on one side and find out the value for it, and then find one angle and plug and use the sine inverse function or the trigonometric inverse function to find one angle, and then plug it into the general solution. This general solution is a representation of all your solutions, not just the angles from 0 to 360, which is what some of you guys have learned previously. And I'm just going to go over how these make sense and why these make sense. But if you guys want to remember the formulas, that also is fine. But this is just kind of like making sense of why we have these. So I'm going to use the unit circle as an example to kind of like have you guys understand this part. And so if you wanted to find cosine, so we're going to look at the unit circle. On the unit circle, remember that cosine actually represents your x value. So since you have the square root of 3 over 2, you have to look on the unit circle. Okay, where else is there a square root of 3 over 2 on the x coordinate? That is right here. This is on so this angle was 30 degrees. And if you guys look at this x coordinate, this is actually 30 degrees, but on the negative side. So because these are the same thing, one is just positive and one is negative, you guys can represent this by positive cosine inverse. So if you guys get the cosine inverse, remember that this is just representing the angle. The cosine inverse of whatever you have inside, this just represents the angle. So that's just 30 degrees. And then this other angle is the negative portion. So the negative angle. So you have the positive one and the negative one. That's what this means. So this would be kind of like positive 30 and negative 30. They both give you the square root of 3 over 2. And then, so because there are multiple ways of writing this, remember that on the first day, I talked to you guys about coterminal angles. That means that if I'm at this angle and I go a full 360 degrees and end up back in this angle, that still has the same cosine. That still has the same point. So cosine is still the square root of 3 over 2 here. So that means that I can go around the circle n many times. I can go around the circle as many times as I want, and I'll still end up at the same point. So that's why we can add 2n pi. So remember that 2 pi is just 360 degrees. So I'm going around the circle 360 degrees as many times as I want, n many times, and then that will still give me that same answer. And then it's the same thing for this other one. So I can go around the circle as many times as I want, and I'll still get the same answer. So this represents the general form for all solutions. And then for sine, remember that sine is your y-coordinate. So for sine, if this is your y-coordinate, okay, let's go around the unit circle. Where else do we have a half? So half, we have it right here. And then one way of getting to this point would be actually, okay, we're at 30 degrees right now. And then we know that we want to get to this angle. If we go to the negative side, if we go to the negative 30, this is actually 180 degrees across from it. So because remember that this is a straight line across from it. A line is 180 degrees. So to go from this side to this side, that's 180 degrees. So what we can do is we're going to go to the negative side of it. That's why we have this little -1 here. And then we're adding 180 degrees to get onto this other side. So that's what this little pi is about. And then again, we can just do that a couple of times. So, and since they are on opposite sides, that's basically why they have the pi. So that's how you guys can make sense out of this one. And then where n is basically just 0, 1, 2, 3, 4, +1, -1, -2, and -3. Basically any number. You can go around either frontwards or backwards as many times as you want. And then for tangent is exactly similar, but remember that tangent is actually negative sine over negative cosine. And then negative sine over negative cosine is the same thing as saying sine over cosine. So that must mean that whenever you guys have either both positive or both negative, these are exactly the same values. So here you guys have the positive square root. Both of these coordinates are the same. Square root of 3 over 2 is the same thing as so here you guys have the square root of 3 over 2 and 1/2. And here you guys also have the square root of 3 over 2 and 1/2. But these are positive and these are both negative. So because you have both positive and both negative, those are exactly the same thing if you rewrite them over each other. So since these two are the same, you guys can go from 30, go 180 degrees over to get the same exact answer. So you guys are going to take your angle and go around the circle 180 degrees, and that gives you the same answer. So that's how they got this general form. And again, you guys can do that multiple times. So go around 180 degrees, 180 degrees, 180 degrees. Questions? Okay. Questions?
Hi, Professor.
Hi. So this was just a little bit of background. This was just background about why these formulas, why this general form works. But the main conclusion from this is that it's basically to solve trigonometric equations, you guys are just going to have to follow these lists of steps. So you're first going to just want to isolate sine, your trigonometric function by itself. So either solve for sine, either solve for cosine or tangent, get it by itself. And then you can use the trig inverse to find one angle, to find one solution. And then you can just plug it into your general form. So I'll go over that first and then ask you guys if you guys have questions about that. So, for example, So if you're solving for x here, if you guys have this first question, you guys have 2 of sine x minus 1. The very first thing that you want to do is you're going to solve this just like a regular equation. Even though it has a sign here, forget about it. Just think about this like a regular variable. If this is a regular variable, to get it by itself, you know, you want to add 1 to both sides. So that will get rid of the 1 here. And then you would have 2 sine x equal to 1. And then you're dividing everything by 2. So you're dividing both sides by 2. And then you get that sine is equal to 1 over 2. So this is our first step. We just finished it. We just solved for sine x. We just got it by itself. So we got it by itself. And now we can use the sine inverse. So we want to actually solve for x. We want to use the sine inverse to find out what x is equal to. So x is equal to the sine inverse of 1/2. If we plug that into our calculator or use a table, whatever you guys want, you guys can do sine inverse of 1/2, which is the same thing as 0.5, and that's 30 degrees. So that's 30 degrees. 30 degrees, remember, that's just pi over 6. So what we're going to do is that, remember that this little inside part, all this represents is our angle. So instead of writing this negative, this sine inverse, we're going to write pi over 6. So we're going to keep absolutely everything the same. So we have negative 1 to the n power times pi over 6 plus n pi, where n can be equal to 0, negative 1 or positive 1, positive 2 or negative 2, 3, 4, 5, 6, so on and so forth. So this is the general solution for our function, and that's it. That's all we have to do. Are there questions about this? So this might have looked a little scary from the beginning, but don't worry too much about this. This isn't too bad. All you have to do here is literally just solve for x. It's kind of like solving for x. You're going to literally just treat this like a regular equation. So if you guys aren't too comfortable with sine, you guys can switch this over to a different form. You guys can say 2x minus 1 equal to 0. And then from here, just solve this normally. So if you guys want to solve for x normally here, you guys know that you just do the same procedures. So if you do the same procedures, you're going to be left with 2x is equal to 1 and then divide by 2. So you guys get that x is equal to 1/2. Once you guys get this part though, remember that x, we actually let that be equal to sine of x. So what you have to do after that, just change x back into sine of x. And then you just follow the same procedures. But it might be easier to just keep it as sine, or if you don't feel comfortable with sine, you can change it back to x, whatever you guys feel comfortable with. But this is just like solving a regular equation. Are there questions about this? Okay, I will take that as a no. All right, so let me go to the next problem. So here, it's like you guys have, so here you guys have tangent squared plus 2 tangent x plus 1 equal to 0. If you guys can see, this actually has a little squared on top of it. So this, you guys see a whole bunch of like writing on this. The writing may or may not seem confusing, but it's not too confusing. Let me see if I can kind of blur some stuff out. Nope, never mind. Okay, never mind. Okay, so I can't really. So over here, in this question, you guys have a quadratic equation because this has a little x squared on it. It's kind of like thinking like of this like a quadratic equation. So all you really want to do is just try to factor this. Try to factor this like a regular equation. So you know that usually you open up your parentheses to try to factor something like this, and you have to think of 2 numbers that multiply to give you x. Usually you would put an x and an x here. But because you have tangent squared this time, you're not just going to put the regular x, you're going to put tangent x and tangent x. And then from here, you just have to think of two numbers that multiply to give you 1. Well, that's just 1 and 1. And do they add it to give you 2? Yes, they do. 1 plus 1 is 2. So this is how you guys can factor this. So that's how you guys can do this. And then again, if you guys aren't comfortable with tangent, you can always just switch it over to regular x. So this would be the same thing as saying x squared plus 2x plus 1 equal to 0, and then just factor it normally. So this would be x plus 1 and x times x plus 1. So that's how you guys can get that. And then just solve it regularly. So now you're just going to remember that to solve for this, you're going to set both of these equal to 0, and then just solve for a tangent. So get it by itself. So you're going to subtract 1 to both sides. So you get that tangent x is equal to -1. And then on this side, this is exactly the same thing. So you get that tangent x is also equal to -1. And then again, to find out what x is, you're just going to do the tangent inverse. So tangent inverse actually goes by two names. You can either call that tangent inverse or the arctangent. That represents the exact same thing. So if you guys hear arctangent, same thing, arc inverse, tangent inverse. So again, if you guys want, use your calculator, tangent inverse of -1. You plug that in, you get -45. -45 is the same thing as pi over 4, -pi over 4. So you know what your angle is. So we know our angle. So now we're just going to take our angle. Remember that this part here is just our angle. Our angle we know is now -pi over 4. So we're going to take that and plug it in to our function, to our equation. So we have that -pi over 4 plus n pi. So that's the other part. And that's it. So x is equal to -pi over 4 plus n pi, where n is equal to 0, 1, 2, 3, 4, -1, 2, 3, 4, anything like that. Questions about this?
Professor, how do we get tan x plus x parentheses times x plus x equals 0? That one. Where did it get?
Where? Sorry. This part?
Yeah, this line, this one.
This is kind of like my side example.
Okay.
Yeah, this was like an example. This is an alternative. I'm gonna say or.
I mean, tan x plus 1, tan x plus 1 equals 0.
Here?
Yes, that's what I'm saying.
So this is exactly the same thing as factoring. So you can either think about this as, you can either look at it like this. So two numbers that multiply give you tangent squared. Since this is a quadratic equation, you can factor this normally and then just solve for tangent to get it by itself. And one way of thinking about this is by just thinking about how you would usually factor this. Usually, you would open up your two parentheses and put your two x's here, usually. But now you have tangent squared x. So tangent squared x means that you're going to put tangent here and tangent x here. So not just x by itself, but tangent x here. And then again, you just have to think of two numbers that multiply to give you 1. That's 1 and 1. Do they add up to give you 2? Yes. So 1 times 1 is 1, and 1 plus 1 is 2. So that's how you can factor this. And then if you're not comfortable with that, you can also do x squared plus 2x plus 1. Just switch them over to regular x's and then solve for it this way. And then once you solve for x, just plug it back in. So instead of writing x, you guys are going to write tangent x. And then that's how you guys can solve for that way. Are there questions about this? Okay. So yeah, so this isn't too bad. You just have to think about, it's basically just like solving a regular equation. But I'll go do one more with you guys, and then I will have you guys practice some if we have time for that. Okay. So then for this one, you guys have cosine squared x plus 7 cosine x plus 6 equals to 0. So again, this is a quadratic equation because of this little square. So if this is a quadratic equation, then you can try to factor it. So you can try to factor this. So again, instead of writing just regular x, we're going to write cosine x. So we're going to have cosine x and cosine x. And then two numbers that multiply to give us 6 that add up to give us 7. That's 6 and 1. 6 times 1 is 6. 1 plus 6 is 7. So that's how you guys can get that. And then again, since these are both equal to 0, we can set this equal to 0, and then this equal to 0, and then we just solve for x. We'll solve for cosine x. So remember, first we're going to try to solve for cosine x and get cosine by itself. So we have to add 6 to both sides, and so now we get that cosine x is equal to -6. That's on one side. And then on the other side, we can subtract 1 to both sides. So we have cosine x is equal to -1. So we got the first step. We solved for our, we got the first step. So we solved for both of our cosines. But here, so now let's actually find the inverse. So remember that we can find x by taking cosine inverse of -6. But when we do that, we get cosine x of -6. We get not a number. It does not exist. And the reason why that is because on the unit circle, cosine and sine only go up to -1 and 1. So both of these are only going up to 1 and -1. There is no way for us to get -6. -6 is not on this circle. Remember that the unit circle only has a length of 1. So it's basically anything. And this n, so this n actually represents all the numbers. So it keeps going. So this can be 0. So this just represents how many times around the circle you're going. So you can go around 1 time. You can go around 2 times, 3 times, 4 times, 5 times. You can go around the circle as many times as you want. That's what this little n means. So you're going 2 pi. Remember that 2 pi just means that you're going around a full 360 degrees. And the n represents that you're going around it several times. So you can go around 1, 2, 3, forwards or backwards. If you're going around backwards, that represents a little negative sign. So that's so that represents that you're going backwards as many times as you want, n many times. That's what the little n represents. So now, so from there, so we know that this cannot be an answer. And now we can find out what cosine of x of -1 is. So cosine x of -1, we can again plug that into our calculator. Cosine inverse of -1 is 180 degrees. So since it's 180 degrees, that's actually equal to pi, because remember, they're the same thing. So now, let's actually look at the unit circle. So over here, we have pi. So pi is actually equal to, where is this? This is cosine. So here, cosine. Okay, so yeah. So we're gonna actually go around here. So cosine is actually we're actually gonna have plus or minus pi. Plus or minus pi. That just means that, and we're gonna go around that 2 times. So we're gonna go around that, so we're gonna go around that 2 times. But remember that here, we only use this plus or minus sign because it can possibly end up in the same place. Let's actually go around the circle 180 degrees. I mean, 360 degrees. Let's go around the circle 360 degrees. If we go around the circle 360 degrees, we end up in the same place. So because we end up in the same place, no matter where we go, this is still just considered pi. So we don't even have to worry about this plus or minus sign. The plus or minus sign only comes into play if one of them is in opposite corners. So remember when we went back to the 30 degrees? Remember when this was 30 degrees and this was negative 30 degrees? The negative signs mattered because those were two different angles. But here, since it's on the x-axis, no matter how many positive pi is here. If you go around, positive pi is here, but negative pi is also here. So they're both in the same point. So there is no difference between positive or negative. So positive and negative pi is the same thing as just regular pi. So x is just equal to pi plus 2n pi, where n is equal to 0 plus or minus 1 plus or minus 2, 3, 4, 5, 6, keeps going. So that is how you guys can do this part here. Are there questions about this? Questions, comments, concerns? Yeah, so it's just pi over, so it's just x is equal to pi plus 2n pi, where n is equal to 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, keeps going. And that's because plus or minus pi is exactly the same thing. So if you start off at 0, and go around positive pi, you end up here. If you go negative pi, remember that negative pi is backwards, you also end up here. So it's exactly the same point. Plus and minus pi is exactly the same point. You end up in the same place. So that's the same thing as just regular pi. Yeah. Any other questions? If not, you guys can start to try this out. You guys can try these three out. We probably won't have a chance to go over them yet. We'll go over them next time, tomorrow. But you guys can try these out, and you guys are just following the same exact steps. So first, get cosine, tangent, or sine by itself, and then solve for x.
Professor,
Yes.
can you give us that formula on top?
Okay.
How you do? Thank you.
Who are you in cosine? Oh, hold on. Let me just bring down all of them. Can I copy? So these are your steps. So you're first doing this, then this, then this. yeah, so we won't have time to finish this. Well, have time to go over it. But I'll give you some time tomorrow to work on this as well. But does anyone have any questions for me? You guys can keep working, but I'm just asking questions. So your final is actually going to be on August 6th. So that's next week, I think. What week are we in? Yeah, that's next week, guys. This class is almost over. You guys are almost through the whole thing. But this is our last week of meeting. And so we actually meet until the end. This keeps going up until so you guys are we're gonna meet throughout this week and then part of next week until your final. That's at least from what I understand, from what they have told me. So yeah, so we will keep going, and then we'll go through this week and finish up the material. And then next week, I will try to have 1 or 2 days of review, hopefully, at least one. That way you guys can ask any questions, but I'll post the review sheet. I'll post the review sheet for your final on Blackboard, and then you guys can take a look at that. That also includes, should I provide the answers? Yeah, I'll provide the solutions for them. So those will also have the solutions to them. And then so you guys can try them out and check your work. And then we can continue from there. And then you guys can, and then on the day when we have review, I'll go over any questions that you guys have about those questions. If you guys have questions about that you weren't too sure of, I'll go over that during the review day. But yeah, you guys can try them out. If you guys want to start reviewing, you guys can definitely share the work for that. Oh, Ola, you started sharing. Ola, we actually ran out of class time. Thank you for sharing. You can actually share this tomorrow if you would like. I don't want to go too over class time.
Okay.
Yeah, because it's 11 now. No problem. So are there any other questions before I end today's lesson? All right. So yeah. So I will be posting your exam grades on Blackboard. And again, I announced that there is a optional 4th exam if you guys would like to drop one of your lowest grades. And then if you guys don't do as great on that exam, don't worry, because you guys, I'll just take the highest grades, the 3 highest grades that you guys have, and you guys can take it as practice, because if you guys want more practice, because it will be cumulative in the sense that it will cover other things learned outside of this week. But yeah. All right, guys. Take care.
Thank you.
Have a good day, guys. Okay. I'll see you guys tomorrow.
Bye.
Bye.
Bye-bye.